on the review thingy here. Okay, number 10 says solve by completing the square. That's an excellent question, because what makes this one tricky? Does anybody know why Haley White picked this one? What? This is off the review. We don't have time to do every problem, so I said you should look it over and see what you had questions on. And Haley picked number 10 right here. Let's see if I can make this a little bigger. Okay, anybody know why Haley picked this one? It's completing the square, so I'm going to move the constant term over to the other side by adding 85. And then I'm going to put a blank on each side. But I'm thinking the reason Haley picked this one is because we have to work with fractions. One of those dreaded math F words. Because to take half of the b value here, we're going to end up with p plus 5 halves. And you should leave it a fraction. Did everybody find their review packet? Does anybody need another copy? Are we good? This is number 10. Okay? The next step for this would be to square that and add it to both sides. 5 halves times 5 halves would be 25 over 4. Does that part seem to make sense, Haley? Okay. Now what we need to do is add these together on the right-hand side and make it into a fraction. Let's see how this calculator works. If we type 85 plus 25 divided by 4, I got 91.25. Now, I believe there's a fraction button that will turn it into a fraction. I can't see this. It's not fraction into decimal. Oh, it's decimal into fraction, though. Okay. Do you see above the PRB button, it says F to D or D to F? So if you do second and then that button, it will change it into a fraction. Unfortunately, mine gave me 91 1/4. Is that what you got? Okay. We need it to be a mixed number. I'm sorry, an improper fraction. My vocabulary is lacking today. So if you use second and then the ABC button, it will now change it into 365 over 4. That was kind of a complicated process. Now, what you could have done, it was 91.25 when you got the decimal, right? You could have said that's 91 1/4, and then do you remember the old 91 times 4 plus 1, and it all goes over 4 thing you did to make an improper fraction back in elementary school? Okay, so that's how they got 365 over 4, because I don't know if I would remember all those buttons. What? Yes, you could definitely get a common denominator and add them back here is what Martin's asking. Yep, but somehow you got to come up with an exact fraction. What's the next step to solving this, guys? Square root. So we get p plus 5 halves equals plus or minus the square root of 365. Nobody would have forgot the plus or minus, right? What happens in the denominator, though? The square root of 4 just becomes 2. So now I need to subtract the 5 halves over to the other side. So I have p equals negative 5 halves plus or minus, and you could make it a single fraction if you want. 365 is divisible by 5. But I don't know what we get. 5's not a perfect square. We get 73, which I think is a prime number. So yeah, this isn't going anywhere. So it's just square root of 365 over 2. You could have also written that as one giant over 2 thingy. Okay? Okay, so one more time, just so you have it if you want it. I typed 85 plus 25 divided by 4, and it gave me 91.25. Then there is a second PRB, which is the fraction decimal button. And then we went second, the ABC button, so that it changed it into a improper fraction. Anybody read what it says above there? Anyway. D over E. Thanks. I can't see. So those are the buttons we used to change things if you really wanted to practice it that way. But practice one that's odd because it will be on the quiz. Okay, what else can I help with? Okay. Can you try that one on your own? That one's even, so it should be a little bit nicer. It's already got things moved over, so we just need a blank. So half of this would be 8. 8 squared would be 64. 16 plus 64 is 80, maybe. Then if I square root, and remember my plus or minus, this is 4 times 20, but 20 is divisible by 4 again, so yeah, not 8. Yeah, you could do 4 times 4 times 5. And then just remember that this is going to square root to be a 2. This is going to square root to be a 2. So you get 4 square roots of 5. It is 16 times 5, or 4 square roots of 5. If you have trouble with simplifying radicals, there's some extra practice at the end of the review. And I can make sure you have the answers to those if you need to check them. Then we still need to add the 8 over there. Be real careful. When you add 8, it should say 8 plus or minus 4 square roots of 5. Yeah, be real careful when you have a minus in here and you take that half. It is a minus here, minus 8, okay? So that's a mistake that a lot of people make. Are you good? Anybody? What else? Did you need to see any factoring? We skipped all the factoring. What is the difference between 1 through 4 and numbers 5 and 6? Because I need to make a huge deal about this because people do this wrong. Okay. Yes. Do not solve these, right? Because they don't have an equal sign. Everybody good with that? I get answers to problems that don't have an equal sign. That's wrong. Let's just do, which one do you want to do? Number 1, maybe? There's a lot of factors for 6 and for 18. I think on number 2, you could maybe take out a 4 or something before you start that one. But, you want me to try 6 and 1 or 3 and 2? Don't tell me the right answer. Just tell me what you want to try. 3 and 2. For 18, you want to try 6 and 3, 9 and 2, 18 and 1, 6 and 3. If I try 6 and 3, I actually know it's not going to work because, remember I talked about this, I think, briefly yesterday. You could take a 3 out now, right? And you can't take a 3 out up here, so that's not working. If I switch this to a 6, you could still take a 3 out. So I don't think 6 and 3 is going to work for us. Unfortunately, now I need to find my undo button. How about 9 and 2? If I did 9 and 2, the 9 would have to go here and the 2 would have to go here. Oh, I think we might be in good shape. What do you think? This makes 27 and this makes 4. Now we needed a negative 18 and we need a negative 23. So if we had negative 27 plus 4. But again, you just have to keep trying and keep track of what you tried. And it should foil back together. All right, you want me to do 3 or 4? I would like to do one of those cubics. Okay, number 4. What is the cubed root of all that mess? 5x minus 3. Okay. The second parenthesis becomes 5x times 5x, which would be 25x squared. At the end is 3 times 3, or 9 plus, yep. In the middle goes one of these times one of these, which would be a 15x, but the rule is if this was negative up here, this one stays the same, and this is the opposite. Oh, I missed a squared. Sorry. I should have a squared right there. Yeah, it's probably right off the review. I don't know. There's only so many perfect cubes that I'm going to make you know, so. Well, up to like 7 cubed, maybe. If you just recognize them, you can always type on your calculator. You know, I'm not taking your calculator away, so. What else? You want to do one of these solve by factoring? What would you have to do first on 6? Yeah, it's got to equal 0. So we're adding 7. Be careful. Now, I think we're in pretty good shape because 5 and 7 are both prime numbers, right? So the only way to get 5k squared is to have 5k times 1k. And the only way to get 7 is 7 times 1. Where do you want to multiply the 7? Not by 5. That's not going to give us 12. So I think here. So we'd have 7k and 5k. And the inside outside. We need a positive 7, but a negative in the middle. So we need 2 minuses. So then if we solve, because this did have an equal sign, we get k equals 7/5 or 1. Everybody's okay? Is that enough factoring? All right. Solve by square rooting. What's the big deal you got to do there first? Divide. Okay. Yeah, for this one, you would divide both sides by 5. So you'd have b minus 7 squared equals 12. Then when you square root, you got to remember what? B minus 7 equals plus or minus. 12 is 4 times 3. So that will become a 2 times the square root of 3. But I also need to add 7 over there. 7 plus or minus 2 square roots of 3. All right. Does that take us all the way down to quadratic formula indiscriminate? Okay. Solve by quadratic formula. You have to know the formula, and it's on the quiz, so make sure you get it. I sometimes get signs. People do weird things with signs, so be careful, you know. It's b squared minus 4ac. Sometimes somebody gets a plus. I usually write it with a parenthesis in here just to reinforce that, but you definitely don't have to. Should we try 11, or are you good? 11 has a negative 1 for a. That's weird. Okay, so the opposite of b would be positive 11 plus or minus b, which is negative 11 squared, which should become positive 121. But then it's minus 4 times A, which is negative 1, times C, which is 8. Please make sure you know how to use the calculator and get the right sign out of that inside business here. So we should get 11 plus or minus 150. This was 32, 153. Square root of 153 over negative 2. Is that going to simplify? This is 5 times what? 31? 31 is prime. It's not. What? It is 17 times 9? Oh, 3 goes in here 51 times. I said 5 goes in here. I'm like so confusing myself. Thank you. It is an icky one. It's 9 times, you said 17? So we get 11 plus or minus 3 square roots of 17 over negative 2. You could distribute the negative to the top instead of the bottom. It just doesn't matter. But I wasn't tempted to cancel anything. I shouldn't on that one at least. All right, I can do more quadratic if you want me to. Yes, no? There's 2 more here. What? 13? So 13, it has to equal 0 first. So if we add 8 over here, we have negative 3x squared minus 12x minus 8 equals 0. You actually, if you wanted, could change all the signs because you could multiply through by a negative 1 and solve 3x squared plus 12x plus 8 equals 0. Anybody have a preference? You want me to leave it the way it was written, or? Okay. So let's practice this way. You should get the same answer, though. Opposite of b would be 12 plus or minus the square root of negative 12 squared should be 144. Then it's minus 4 times negative 3 times negative 8, which should be a minus, I think, all over 2 times negative 3. So 12 plus or minus, this is 144 minus maybe 96, I'm guessing. 24, 48, 96. 144 minus 96, 48. Anybody checking me? If you're not getting that, we need to talk. But this is a great question because this is where students start dividing out things they shouldn't, right? So be real careful. I would just do 12 over negative 6 plus or minus over negative 6 back here. What can we do to 48? 4 and 12, but then 12 would reduce again by 4. So you could say it's 4 times 4 times 3. It's actually square root of 16 times square root of 3. So 4 square roots of 3, yes. Now this is a kind of weird one because you can have a couple different answers. If you do what I did and separate it, this would become a negative 2 plus or minus a negative, which really doesn't matter because it's already plus or minus. 2/3 and a square root of 3 is on top. If you just reduced all of these right here by 2, you would have 6 plus or minus 2 square roots of 3 all over 3, or negative 3. And this is actually equivalent because it has a common denominator here and it's simplified here. But either this bubbly answer or this bubbly answer is right. This one is in the box is not reduced enough. Yeah, that's kind of hairy at the end. I would be fine with you separating it and leaving it like I had down at the bottom. All right, what's the discriminant, guys? Okay, b squared minus 4ac. But what does it tell you about the number of solutions? Okay, so if you get a discriminant that's what?
Greater than 0, 2 or more.
2 at most, but yes. Greater than 2. Okay, greater than 2, that's a thing. It is a thing, but it's not going to tell us anything. Greater than 0 would be 2 solutions.
Less than 0 is 1.
Yes, equal to 0 would be 1 solution. And less than is, you can say no real, or if you really wanted to, right there, you could say too complex, but you don't have to. So how do you find the discriminant on 14? All right, well, on 14, is there a b term? No, it's 9a squared plus 0a plus 2. So this is a, b, and c, which is weird because they use the letter a in the question. But b squared minus 4 times a times c would be negative 72. Did I do that right? So the discriminant is negative 72, and there are no real solutions. Do I need to do the other one, or you got that? This one would be b squared minus 4ac. That's going to be positive, all right? 148, maybe? So there's 2 real solutions. All right, I'm moving on to imaginary numbers. Be careful, because what generally happens that people make silly mistakes, because if it says this, someone usually foils it together, okay? Be real careful. If there's something going on in here besides multiplication, you're not foiling it, right? All right, so what do you want me to do out of these choices? The first one, what would you get? Add like terms. 7 minus 3i. The one underneath it would be 7i minus 7, then minus a negative 6i would be plus 6i minus 2. I just distributed the negative, so then I'd have 13i minus 9, I think. Did someone else get that? And the book would always put the real part first, so they would write negative 9 plus 13i. I totally don't care, okay? All right. These are foiling questions. Do you need me to do one of those or not? What? Which one? The top one? Okay, so this guy up here, negative 2 times negative 2 is 4. Negative 2 times negative 7i would be plus 14i. In the middle here, we have a negative 7 times negative 2 would be plus 14i again. Negative 7i times negative 7i would be plus 49i squared, which becomes 4. We can add these together if you want and get 28i. But back here, it's 49 times negative 1, which becomes a negative 49, right? So negative 49 plus 4 is negative 45 plus 28i, or 28i minus 45. Is that what you got, Xavier? You good? Yeah, I didn't do that one in the middle, but it's just a FOIL question. Most common mistake there is sign mistakes, right? You just got to be real careful. Take your time. All right, what about these? Can't have an I in the denominator, so you have to do what? the conjugate. Very good. Multiply top and bottom by the conjugate. Be careful. -9 minus 2i. Only the middle sign changes. The sign on the imaginary part. All right. Foiling the top gives me what?
90 minus 30.
36. Okay, that was that one. What about -2 times -10? Positive 20 i's. 4 times -2 is -8, but that one was an I squared, so it's going to become what? A positive 8. The denominator, -9 times -9 is 81. What should happen if these are conjugates? The middle term should drop out. Negative times a negative is plus 18i. Positive times a negative is negative 18i. Then 2 times -2 is -4i squared, which will become plus 4. So on top, I have 98 minus 16i, I think. In the denominator, I have 85. 98 over 85 minus 16i, 85th I. I'm fine with either one of those answers. It doesn't reduce, does it? How many times does 5 go into 85? 17, right? So that doesn't reduce. Well, 5 doesn't go into 6. I don't know. Just ignore me. Anybody remember the trick to this one? You really don't have to multiply everything by the conjugate. You can just multiply by what?
Wouldn't it be 7, no, 81? 77, not 85.
This was minus 4i squared back here. This times this was minus 4i squared, which became plus 4.
Yeah, you had it plus on the bottom.
Yeah, because I went back and changed. I should use a different color when I changed it. Okay, better?
Yeah, I was just confused.
Sorry. Okay. You can, with this kind, just multiply by I, and then you won't have to do so much reducing. So you'd have a 6i minus 9i squared all over a negative 4i squared, which would become a 6i plus 9 all over positive 4. Is that right? And you could leave it like that, or it would be 9/4 plus, 6/4 would reduce to 3/2 I. You don't have to reduce it if you leave it all as one fraction. I wouldn't count it wrong. Proper notation would be 9/4 plus 3/2 I. All right, imaginary good, except for powers of I. Do you remember how this goes? Okay, if it's even, we can just divide out a 2. How many times does 2 go in there? And I can remember I squared is -1. -1 times itself 111 times. If you're going to use your calculator, you got to use parentheses. Should be -1. If it's odd, I don't know how to deal with that. I don't know how to divide it by 2, so I'm going to make it even by taking 1 out. But I'm just going to ignore the 1 out front. 83 times. I squared is -1 to the 83rd would be what? -1. So we get -I or -1I, however you want to write that. More practice on those? All right. That leaves the linear review section of the quiz. And we haven't talked about this stuff for a while. All 3 types, real quick. Anybody? y equals mx plus b, and that is called, yes, slope intercept. Point slope?
y minus y1 equals m times x minus x1.
You know what? You guys did well on that. It was not an issue of the form last time. I mean, most of you at least tried that form correctly. What's the big thing with standard form? A has to be greater than 0, and they all have to be integers, meaning no fractions or decimals. Everybody good? So what do you need to see? Yep. Good, Mark? All right, the one that says perpendicular, it says perpendicular to this. Is there a slope easily pulled out of that? Not yet. Let's see, if I subtract an x over to the other side, I'd have negative 4y equals negative x plus 12. Then I'd have to divide everything by negative 4. Is everybody with me to get the y by itself? Now, I just did a whole bunch of work that got me a 1/4 x minus 3. I feel like I should be done. But I haven't really even started the problem, right? All I did was find the slope. This is the original slope. So I need the perpendicular slope, which would become nicely, flip it over and change the sign. Everybody's good? Negative 4. Now, we don't need this equation at all anymore because the other part of the equation, the other part of the question says we now have to make a line that goes through 1, negative 7. That's a point. This is a slope. So I'm going to start with point slope. Y minus negative 7 or plus 7 equals, the slope is negative 4 for the perpendicular, and then x minus the x value, which is 1. How do I want to leave my answer when I'm all done? Yeah, it said slope intercept, so I got to get the y by itself after I distribute here. It is possible you will have to work with fractions on these and you don't have a fraction calculator or a graphing calculator that I got the hiccups. On this one up here, you would subtract the 2x over to the other side. Oops. This would be plus 9. And then because it says parallel, you would just use the slope of negative 2 and this point, right? And then get the y by itself. Don't need me to do that one? Anybody? All right, line through 2 points in standard form. Yikes. That's a lot of work. What do we have to start with? Slope. And what's everybody going to do wrong? They're going to put the x's on top. Don't do it. X, y, x, y. So if I just go 2 minus 7, negative 3 minus negative 6, be very careful because most often it is a sign mistake that kills you. Oh, great. It's a fraction. Okay. Which one you want to use? Because you got to use one of those points in that slope. It isn't going to matter. You want to use this one? So it's y minus 2 equals negative 5/3 x, quantity x minus negative 3 or plus 3. Again, the most common problem in these is sign mistakes. y minus 2 equals, when I distribute, negative 5/3 x. But if I type on my calculator, negative 5 divided by 3 times this 3 back here, I just get what? Should just get negative 5. Okay, standard form can't have fractions. You can get rid of them now, you can get rid of them later, but at some point you got to get rid of the fractions. You want me to add the 2 first? So I have y equals negative 5/3 x minus 3. Now you want to get rid of the fractions or move it over first? I don't care. Yes? Which one? Add it. So I'm at 5/3 x plus a y equals a negative 3. Now I got to multiply everything by 3. And when I say everything, I do mean everything. So what do I get?
5x plus 3y equals 21.
I don't have a 7 over there. I have a negative 3.
Oh, yeah.
Negative 9. Do you see where there's a lot of room for a sign mistake in a question like that? So go through it twice, use your calculator, check yourself before you wreck yourself. You have to do a retake. Okay. Application problem. A bakery charges a flat fee for a cake, then adds to the price based on an hourly rate to decorate it. That's not us. If a customer's cake took 6 hours, it costs $233. Now, if you're not sure how to write that, like which way the ordered pair goes, down here it says the cost where X is the number of hours. So 6 hours is the X and 233 is the cost. And then it says a different cake was 4.5 hours and cost $194.75. Well, could we make nice numbers there, half hour? How do we find the cost per hour? The cost per hour is really just the slope. Yeah, the rate of change or the slope. Yep. 233 minus 194.75. Please, someone have a calculator. 525, 38.25 over 1.5, and yep, I give up now. Because that's not nice. 25.5? Is that what you said? Okay, so it's $25.50 an hour. Did someone else get that to decorate a cake? Oh, they charge a fortune, some of those places. You think all those cake people on TV don't get good money? All right. Yeah. Now how do we come up with an equation, though? Okay, this is the slope. So I would use point slope. Yeah, y minus 233. I just picked the first one because it didn't have as many decimals. Equals 25.5 times x minus 6. Y minus 233 equals 25.5x minus 153. That's probably wrong. Okay. Plus 233. Is that positive 80? So we get 25.5x plus $80. $80 for the cake. Yeah, I hope it's a darn big cake. Use your model to predict if it takes an hour and a half to decorate. So 25.5 times an hour and a half plus $80 give us some cost. All right. Anything you need to see another one of? I can go back and do a factoring problem. I can do another quadratic problem. We could talk about some of the stuff at the bottom, simplifying radicals. There's more factoring practice just for fun. We got 4 minutes. Anybody? Haley, one you want to see? No? Cameron, anything? Jack, which one you need me to go back to? Did you need me to just put one up here for you that we already did? You good? Is it Caden? Is it Caden is right name? You nothing? Good? You're good? Brandon, you're good? Okay, if you have your homework check done and you want to turn it in today, you can. If you want to hang on to it tonight because you're going to look back over something or practice some extra examples, feel free to hang on to it till tomorrow. That's not our bell for 3 more minutes, so